Quality management and control. Today we are going to study a very key topic. Quality is often a top concern for companies, for consumers, especially when it relates to things including safety. For example, for automobiles, safety can be considered part of quality. A higher quality car is supposed to be safe. So this is an issue that you might hear about in the news. This is an issue that you deal with in management a lot. So hopefully, we'll cover some topics that will help you think about this topic in ways that can help you improve quality in your organization. So quality management is not a new topic. The concern for quality is not a new concern. The earliest references that I've come across mentions of quality or quality management that in the code of Hammurabi, who was the ruler of Babylonia, which I believe is modern day Iraq, at least 2000 BC or more, was this law or rule that the mason who builds a house, which falls down and kills the person living in the house, inmate, the person in the house, that mason will be put to death. The idea being that the mason did not, if the mason had built a quality home, it should be safe to live in. And thankfully today, quality mistakes tend to not be that disastrous for managers, where managers are held personally liable for them. But quality mistakes today can cost lives, especially in products. Imagine you're designing a self-driving car and there's some quality issues and the car crashes, right? So lives could still be at stake. What are we going to talk about today? We're going to talk about what is quality and the costs related to quality. And then we are going to jump into quality control. So a bulk of our talk is about quality control. And we're going to cover two topics there about process capability. We're going to learn about that. And then we're going to learn about statistical control of processes to make sure capability is about making sure a process has the capacity to produce quality output. Or the capability to produce quality output, and then the process control is to keep it that way so that it continues to produce quality output. So what is quality? I'm sure if you ask this question to anybody, most people would have some view of quality in their heads. They'll be able to tell you what they feel is quality. And it is important to be on the same page when we talk about quality. And quality is a broad concept. There are many things that go under quality. Some of the things that go under quality include things like performance of the product or the features in the product. So, a cell phone with a camera or with 3 cameras may be considered to have higher quality than a cell phone with just 1 camera. Same thing for services. If you go to a hotel and they give you free breakfast, that might be considered higher quality than going to a hotel which does not offer you free breakfast. So that's one dimension of quality to do with features, performance of the items. So a sports car which can accelerate from 0 to 60 miles per hour in 6 seconds or 7 seconds might be considered to be higher quality than a car which takes 12 seconds to achieve the same. Then another dimension of quality has to do with reliability. So things that don't fail are considered to be quality things. A third aspect of quality might be meeting specifications, and it's often related to reliability as well. So if you build something if you have a specification in place in the design aspect of the product, you come up with a specification, and that specification is hopefully based on prototyping, testing, user testing. And so now you have a good idea of what a quality output should look like. So you make a specification for it. Then when you produce the output, if it meets that specification, we can say it has some quality because the specifications were chosen in a thoughtful way to encapsulate what the product should be like. And if you're meeting those specifications, then you are going to then you have a product that performs well. Aesthetics could be part of quality. Two products have identical functionality, but one looks better than the other. So you could think of when people buy cars, if there are 3 or 4 cars in the same category and similarly priced, a consumer might say, oh, this car has a more modern look and feel, and that car may sell better. A common example of this is Apple, where they really focused on the aesthetics of the product and not just the technical specifications. For a long time, Apple products would have lower specifications in terms of computing power and memory than corresponding, Windows or Android products, who would give you more raw memory on the device and more, gigahertz or megahertz of their chips. But the Apple product would be more user-friendly to use, or have better aesthetics and have enough performance that it was still snappy, right? So aesthetics, the user experience with the product, and the look and feel of the product can also be part of quality. So quality is multidimensional. And when we talk about quality management and control, you could talk about one or multiple dimensions. We are going to define, how we are going to look at quality for the purpose of this class. And essentially we say quality is lack of defects. Okay? A defect can be defined in a couple of different ways. What is a defect? A very common definition of a defect that's used within organizations is that a defect is not meeting the specification. So if you're building a product and something has to be a certain length and it's shorter or longer, that's a defect because it's not meeting the specified length. If you're supposed to have an electronic device which is supposed to work at a certain temperature, ambient temperature, is supposed to produce certain outputs like a display or certain signals, and you have that specification, you can test it against that. And so, for example, if you have a car battery or any battery and it fails in winter because it was supposed to work till 0 degrees Fahrenheit, but practically when you get close to 0 degrees, it stops working. That'll be like a defect. It did not meet the specification. More broadly, so that's a more narrow definition of a defect. Defect is failure to meet specification, right? A more broad definition of defect would be if a customer is unhappy or unsatisfied, then you have a defect. Okay. Any instance when a process fails to satisfy a customer would be a defect for that process. And we also have to understand that we may have different versions of the product targeting different customer segments. And so we may have some things by design that a customer may complain about or not be happy about. And then we may not term that dissatisfaction of the customer as a quality problem. So for example, on a budget airline, if you find a very low cost ticket on a budget airline and you go sit in the economy class and there's not enough legroom, That's by design. The company traded off legroom to be able to put more seats to reduce the price per seat. And so you paid less for that ticket too. So if a customer complains about legroom, the company is not going to go and change their layout of the airplane, because that's by design. They designed that product for a certain customer segment in which customers care more about price than comfort, and so you're trading that off. You're giving them a less comfortable journey, but they pay less. Sometimes customers will not be satisfied because the product is fine, but they were not able to install or use the product properly. It was complex to install or use, or at least more complex than the ability of some customers. You might see this in networking equipment. Sometimes if you go to Amazon or Best Buy and you look at wireless routers or other things, you find people reviewing certain products poorly and saying it doesn't work. And you can tell from the comment that they don't know how to install it or set it up properly, or their situation is such that the installation or setup is a little bit complicated. And would that be a defect or not? So if you look at our two definitions, the narrow and the broad, our narrow definition was defect is failure to meet specifications. In this case, of a complex networking equipment install, the specifications were not an issue. The product perhaps was meeting specifications. If you look at the broader definition of defect, is failure to satisfy the customer, or when customer is unhappy. So in this case, this would be a defect, right? And you don't want to pick one of the two definitions. You want to use both, because you might say in this case that we have a defect, but it's not a manufacturing defect. We manufactured the product correctly, but it's either a communication defect where we didn't give easy to understand instructions on how to set the equipment up. And sometimes you want to give them a printout with pictures and instructions, but you also want to give them a QR code which takes them to a video to show them a video. Maybe have a helpline they can call if they have problems. So it could be that customer service aspect and communication aspect where they don't have support. And so that's the defect, it's not a manufacturing defect. But it could also be a design defect. The product was not designed to be user-friendly. It was designed to be installed by network engineers in companies, but it was not designed to be installed by the average person in the home. And now you're selling to the average person in the home. And so you have a design defect where the product design is not appropriate for the customer it's being sold to. And so if you only take the narrow definition of quality, that quality is lack of defects and defects are failure to meet specification, then you miss out on defects like having a product that's easy to use, or not having a product that's not easy to use, that's not easy to install, that's not easy to set up, that doesn't have good instructions with it. All of these things you'll not count as a quality problem and never improve them, and that could hurt you, right? So work with a narrow definition and a broad definition of quality. Some things that are quality problems may not be manufacturing quality problems, but they could be quality problems with other aspects of the process or the organization, and you still want to fix them. So what are the costs of quality, costs related to quality? And often when we talk about quality, we want to look at prevention costs and failure costs. Prevention costs are what does it cost you to avoid having a quality problem, to prevent defects. And a failure cost are costs associated with when a defect does happen, what is the cost to resolve it? So failure costs could include something like a product recall. So if you have a car with a problem and you might have experienced that. You go to the dealership for an oil change and they say, oh, we see there's a couple of recalls in the system. We can take care of that for you. You don't have to pay for it. Manufacturer will pay for it. And they update the software in your car, or they change some component because there was a quality issue, and the automotive company had to do a recall and fix those vehicles which had that problem. This is when the defect is discovered after a certain amount or some of the product at least has been sold. So that will be called like external failure costs. If the company is not doing a product recall, some customers could sue it on warranty, could file warranty claims or sue it for selling a faulty product. So right now, I just got this notification about a class action settlement with Honda. And so Honda had this feature where if you press brake and you come to a complete stop, it turns off the engine, because if you're waiting on a traffic light for 3 minutes, according to Honda, we don't want to keep the engine running and use up gasoline. And then when you let go of the brake, it restarts the engine. Okay. To me, it doesn't sound like a great idea. If you have to take a left turn based on a gap in the oncoming traffic, you want to be able to leave quickly from your stopping position. And then when you let go of the brake for a car to start up, it's going to waste a precious second or two. And you may not be able to make a quick left turn, especially in busy cities. It's also not a great idea because each time you start the engine, there's some wear and tear that goes on. And so you're increasing the wear and tear that happens in car engines, because instead of just starting the car at the start of your trip, right? Because your number of car starts would equal number of trips you make usually. But now, even within one trip, each time you stop, then you have the engine shuts down, then you start it again, shuts down, start it again. And so many times more starts are happening over the lifetime of the vehicle than they would without this idle stop feature that Honda built in. And so people sued Honda saying that we have to now replace certain coils in the engine, starter module which starts up the engine, or certain other things. These parts are failing at a higher rate, have more wear and tear because of this auto idle stop feature. And so we have to spend money, even though it's Honda's fault that they put in this ill thought of feature. The other problem is you can't turn it off in Honda, or at least in some models of Honda, like turn it off, because if that was an option, people just turn it off, and then it will be your responsibility. If you don't like it, or if you're worried about the cost of repairs, just turn it off. I mean, you can turn it off, but it only turns off for that trip, and then you shut down the car and restart it, it automatically turns back on, at least in some models. And that's, the auto idle stop thing was not a great decision, but this is an even worse decision. Because if it doesn't make sense for a customer, they can't just opt out of it, right? So this class action lawsuit is an external failure cost of a quality issue at Honda, loss of goodwill, reputation, product returns, product recalls, warranty claims, class action lawsuits. All of these are part of external failure costs. Then you have internal failure costs, which happens when you detect the quality problem in-house before the item leaves your factory or facility. So on the assembly line of the car itself, you find a problem in the car, or you do a testing step at the end of whatever item you're making. If it fails the test, you have to kind of figure out the problem and fix it. And so rework, diagnosing the problem, fixing it, replacing a part, all of this costs money. Any defective items you have to trash, scrap, that costs money. Then you have ethical failure costs. These are costs due to deceptively providing defective products and services. For example, there was a scandal about lead in certain toys. There was the Volkswagen emissions scandal, where Volkswagen had a software where they detected if the car was in an emissions test, it just lowered the amount of fuel the engine used, because power output was not a concern. It was just getting an emissions test. And based on that, they were able to pass the emissions test, but the emissions during the test were not representative of the emissions of the car on the road, right? And that could lead to fines. So the ethical failure costs, how they're different from external failure costs. External failure costs are more between the company and the customer. But when you have ethical failure costs, the government might get involved, or law enforcement may get involved. It has bigger reputation damage than external failure costs. External failure costs, you didn't know about the problem, right? Everybody makes mistakes. External failure costs like an honest mistake. You were not trying to make a mistake. You were trying to do everything right, but then something happened. Whereas ethical failure cost is you made a bad ethical decision. So you kind of knew this was an issue and you let it still go, or you created the issue based on trying to optimize something else, and you didn't factor in this issue, things like that. So these are all costs of quality failures, and we can see they can be pretty large. So to avoid these quality failure costs, we have to invest in quality, and that is called prevention costs. So you may have appraisal costs where you keep track of quality problems in the company, keep track of defect rates, keep track of improvement efforts, and you diagnose what's causing the quality issues, right? All that analysis and diagnosis and performance evaluation, all that is part of appraisal costs, which you have to do because you want to keep a handle on your quality. And then once you do detect issues that need to be fixed, you're going to have some cost to make changes in the organization so that that issue goes away. So you may have to do training of the employees if they were not sure and they were making some mistakes. You may have to implement Poka-yoke, which is mistake proofing. So you set up your equipment and factory in a way that you can't really make a mistake. So imagine, you're building a computer, you're connecting lots of wires with each other. You could make it so that the wires only connect the right way. You can't connect them in an opposite way, which could cause like a short circuit or something. So you design the connector to connect in the right way, so then nobody can connect these wires. The connectors are designed in such a way that they only slide in the right orientation. If you change the orientation, they don't slide in. And so that could be an example of Poka-yoke. In McDonald's, for example, if you take a basket of fries and you put it in the hot oil, you don't have to remember to take the basket out or the fries will get burned. It has a timer and temperature sensor. It keeps the oil at a certain temperature. And when a certain time passes, it pops the basket above the hot oil so that the fries stop getting fried and they don't become dark and burnt. So that's another example of mistake proofing or Poka-yoke. They have to do training, Poka-yoke, other things to avoid quality problems. So that would go under the prevention costs. Now, people have observed over time that prevention costs are usually much less than failure costs. And so you would expect everybody would just invest in prevention and we wouldn't have so many failure costs because, everybody kind of knows that prevention costs are going to be less than failure costs. Well, in hindsight, but the issue can be that short-sighted managers might say, oh, the prevention cost is this much, I can see it. There's no failure cost yet, which is tangible because failure has not occurred. You're kind of thinking, oh, if a failure happens, this cost might be incurred, or you might get away with it. Short-term focused managers who are just trying to minimize costs for the current quarter to make a bonus or something like that, they could cut corners and minimize or reduce prevention costs, which may lead to more defects, which may eventually lead to more costs and higher level of costs. So you have to remember that even if you don't know the exact values of the failure costs, quality failures, you should work on the assumption that the failure costs are going to be more than the prevention costs. So it's okay, it's worthwhile to invest in prevention. Let's look at an example of failure costs. This is the case of the Ford Pinto, a low-cost car Ford produced to compete with other low-cost models available from other companies. And before the car was released, obviously, these companies test the car to do crash testing. And in their crash testing, they found that when this car was hit from the back, the fuel tank would rupture. The fuel tank was somewhere in the back. However, Ford decided to release it as it is. They decided that it was too expensive to fix the problem, that would change the design, that would change the cost calculation, change their profit margin, and they kind of argued internally, or the way they made the decision was a cost-benefit type of analysis. And this is the point I was making earlier, that these quality failure costs are not known precisely. Like, you don't know exactly what the value of lost reputation would be. You don't know in advance what the legal costs might be, right? So these are not known exactly. So when some costs are not known precisely, it's not that easy to do a cost-benefit analysis. And Ford's cost-benefit analysis was that, well, very few people, the fuel tank would rupture, but probably nothing would happen. If something happened, what's the chance that they would trace it back to Ford? Then what's the chance that they would sue us? What's the chance that they would win the lawsuit? And so because these probabilities are very small, probably nothing would happen, and it's too costly to fix it. We have to modify the cost design, retool the assembly line, increase the material cost of the car, and so on and so forth, right? So they just released the car. And so this is a picture of the Ford Pinto, which says, "Keep off my rear, I'm explosive," which is kind of literally true. And this is a video explaining what happened. So if you want a little bit more details, you can watch the YouTube video linked on the slide. And then there's also a summary of a legal case that happened, which has a lot of interesting details about the case. But the point where I'm trying to make is that in the end, the failure costs were a lot for Ford, a lot more. And in hindsight, they wish they had fixed the problem. And this sort of thing has not stopped happening. If you download the slides and look at the notes section of this slide, I've put more links of scandals like this. So another popular scandal is the Volkswagen emission scandal, where Volkswagen faked emission tests to show that their car was passing the emission standards. And then they had a big legal cost to pay when they got caught. There have been issues with recalls that have been handled well by by companies sometimes, and not handled well sometimes. And so some of the examples, you can find links to them of more recent examples in the notes for this slide. So, this is why quality is not something where it's easy sometimes to do a cost-benefit analysis. It's usually, especially if you're a company who sells a complex product, a product with a big ticket item like appliances, cars, computers, cell phones, people are not gonna put up with being sold a defective product or an unsafe product, and so there's gonna be pushback. So you even if your product is not a high ticket item, quality, the benefits of quality compound over time. As your reputation grows, it builds up. The benefits you get from investing in quality will compound over time. And the cost, if you don't have quality, can also compound over time. So initially, it might just be some customers stop buying your product, but in the long run, it could be you get known as a low quality, a company that produces low quality products and so on. And then that reputation can be hard to change. The benefits of superior quality, I'm sure most of you listening to the lecture, you can just think of these yourself. They're fairly obvious. Your reputation benefits, ability to command premium prices, or if you keep the same price, you'll sell more than competitors because people will say, oh, for the same amount of money, I'm getting better quality. So that could lead to increased market share, greater customer loyalty, lower costs. This is interesting. So obviously there's lower failure costs, like liability costs are kind of like failure costs, after sales service, warranty, legal, things like that. So obviously if you have higher quality, you have less failure costs. But how does quality, especially the way our narrow definition of quality is to be free of defects, where defect is not conforming to the specification, how does that lead to lower production costs? Well, you get fewer rework, you get fewer scrap, you get fewer things to fix for free under warranty, things like that. So that reduces your production costs. Making right the first time helps you reduce your production costs. Then there's going to be fewer production or service problems because you have to do fewer quality inspections, you have to stop the line fewer times, you have to fix things and redo them fewer times. And obviously this increased market share, greater customer loyalty, and lower costs all combine to give you higher profits. Let's look at some history, because when you talk about quality, you often start talking about some quality management system like total quality management, Six Sigma, and these ideas that have crystallized over time and are operationalized as a quality management system. It's important to know their history so that you don't become tied to one quality management system. So you understand the linkages between them, you understand the big picture. So if you look at quality management, as I mentioned, it's a very long history. We talked about the Code of Hammurabi, about the mason building the home. The home has to be safe. We have evidence that the processes were standardized to make the stones from which the pyramids were made, so that they would be line up safely and not going to fall over. Then we have, if we go to the Middle Ages, we have the guilds, which were used to signal quality. So guilds had their own icons or marks. And so if you belong to a guild, if you build something, you put the guild icon on it. And because craftsmen cared about quality, as they produced quality items, their guilds would develop a reputation for quality. So if a new customer comes, or the craftsman moves to a new area and nobody knows them there, just because they belong to a guild that is popular, people would trust the quality of their work. Also, some craftsmen would have their own signature or icon or symbol to have a personal brand. But on top of that, the guilds acted as brands. In the modern times, guilds have been replaced by brands where the brand represents some aspect of quality. In professional fields like law, you may have certain societies or honor societies where membership to a certain society represents some achievement. Right? Same idea as a guild. And then in the corporate sector, obviously you have brands, and companies spend many years and a lot of money to develop their brand to be a certain way. And that then tells, just the brand itself, the symbol or the name, tells a lot to the customer about what sort of quality they'll get or what sort of product they will get. So when mass production and the factory system replace craftsmanship, quality is no longer just tied to individual craftsmen. Now it becomes, tied to companies. In World War II, there was another, World War II was a catalyst for a lot of work in quality management, because in World War II, U.S. repurposed its industry to produce a lot of arms to support Allied forces. When you're producing a lot of arms, you need a lot of rifles, bullets, a lot of military equipment, and you need to produce it fast. Because it's being used in a war, you also have to be concerned about quality. You can't have a rifle misfire or a bullet misfire on the battlefield. It could be the difference between surviving and dying. And so in the production of those weapons, some people were hired to look at the quality, and sampling techniques and quality inspection techniques were developed so that faulty batches of bullets or faulty items would be detected and not shipped out to the battlefield. And so that led to development of the initial quality management techniques. After World War II, there was a strong push to rebuild a lot of economies and countries that were destroyed in World War II. And in this rebuilding effort, there was a lot of demand for all sorts of different products and services. And so a lot of companies were focused on capturing market share producing as much as they can because the demand is there, and the demand is not as quality conscious because there's not a lot of alternatives, right? The supply is like your supply constrained. So if you're supply constrained, people will get whatever they can get. And so some of the people like Shihar, who developed statistical quality control that we're going to study in this lecture in a little bit, they found that after World War II, they had, nobody was calling them for consultancy, nobody was listening to their ideas. People were just focused on increasing production and not really focused on quality control. On the other hand, on the other side of the globe, in Japan, Japan was also trying to rebuild their economy, and they formed this organization called Union of Japanese Scientists and Engineers, JUSE. And this organization was trying to help startups and help people who wanted to do production, help them set up production. And Japan, after World War II, was not known to be a producer of high-tech equipment or high-tech products or quality products. So they were kind of starting from scratch in a way. So JUSE realized that there was a lot of knowledge of production and manufacturing in the US, and they wanted to benefit from that. So they invited these experts from the US over. And it was a very interesting thing happening in Japan. They were so focused on learning how to produce things, to manufacture things, to set up their economy, that Henry Ford's book on manufacturing became a bestseller. They had radio programs discussing quality and Dr. Deming's methods. They would invite Joseph Duran, Dr. Deming, other quality experts to come give lectures to train their people. And they were in constant demand as speakers and consultants, so they went and they shared their ideas with them. And then the Japanese took their ideas, and not only did they implement them, they also improved them. So then, when Toyota company started doing well on quality, some of their ideas started to flow back into the West. So when these quality experts would go to Japan and help Japan, they would also observe the new things the Japanese were doing and kind of bring that knowledge back to the US. So what started as a flow of knowledge from the US to Japan in one way, then started to become a two-way stream where these quality experts were learning from Japanese people as well and improving their methods and systems. Deming told the Japanese industrialists that if you follow these principles, and we're going to study a lot of those principles in this lecture, you will have quality. And if you have quality in the current global economic climate, you will find buyers for your goods and you will grow as an economy. Japanese didn't really believe that. I guess they were not that optimistic. And Dr. Deming said that he was the only one in Japan who kind of believed that statement. But they beat his prediction, and in about 4 years, they established themselves in manufacturing with some level of reliability and quality where they could sell goods on the global stage. A question that some historians have asked is, could Japan have risen after World War II? If you look at the automotive industry, engines, machinery, electronics, 1970s, 80s, 90s, the rise of Japan after World War II. Could it have happened without this flow of knowledge from the US to Japan? Duran's comment is that it would have happened anyway. That they were so focused on improving quality, having world-class manufacturing, that when somebody is so focused and working so hard, they were going to get there anyway. But the help from the US experts just helped them get there faster. So it might have taken them a little bit longer, but they would have achieved the same things. And that seems true when you look at how they improved the ideas they got and how they came up with their own original ideas for quality as well. So in the 1960s, as I mentioned, the ideas start coming back, especially the ideas about making quality a responsibility at the lowest level of the organizations, empowering workers at the lowest levels of the organization to evaluate and improve quality. So Japan had this idea of quality circles, right? This was very different to the US culture. In the US, there's a famous statement attributed to Henry Ford: I need two hands and a brain just comes with them, but I don't need a brain. I've already designed my process. I just need two hands of the worker to come to the assembly line and kind of tighten this nut or bolt and do this action over and over. That's all I need. I don't want the worker to think or do anything else. But in Japan, they were like, we're paying for this whole person, so why should we only use their hands? We want to use their brains as well. So they would tell all the workers at the lowest level, laborers, uneducated workers, everybody, that if you see an improvement, make it. Try it out. So they would have these quality circles of employees that would look at what they were doing, find improvements, find ways of improving quality, then test it out, and if it worked, then institutionalize it and do that. And a lot of the great ideas came bottom up in the Japanese companies, came up from the lowest level of employees, and then they were adopted company-wide. Whereas in the US, it was mostly like top-down. There were these managers who would go and study a process, time it, map it, whatever, find the best way of doing it, design a process, just give it to the workers, and then the workers just execute. The workers don't think about how to do, how to improve the process. And so this is one of the major ideas that came from Japan back to the US, and now it's a part of most quality management systems. They have this idea of Kaizen, these quality improvement events where you get all the workers together and they brainstorm and they come up with ideas to improve quality, having quality circles and things like that. That's why when you look at Six Sigma and some of these quality management systems, you see a lot of Japanese terminology there, because a lot of these ideas were refined and improved and developed in Japan after World War II. Even if the seeds of those ideas started in the US, they really flourished in Japan and then came back from Japan to the rest of the world. There was another thing that also came from Japan, which is very interesting, was this idea in the US that high quality meant high cost. If you wanted to make something cheaper and sell at a low price, it's going to have a worse quality. And this myth was kind of shattered because Japanese were able to create more reliable cars, better electronics at lower costs. And this has to do with understanding that quality has multiple dimensions. Sure, the premium feel, using premium materials, having advanced features, that type of quality of the product often comes at higher cost. But reliability of the product, of it not breaking down, not having defects, this type of quality, which is called conformance quality often, leads to lower cost, as we talked about, because you avoid cost of failure, you avoid scrap, you avoid rework, your production process becomes more streamlined, you have to check quality less, you avoid all that waste. And so this type of reliability and defect-free conformance quality leads to lower cost of the product. So initially, when the American response to the rise of Japanese manufacturers who are offering defect-free, reliable products which are cheaper, was to try to just protect the local industry, have tariffs, import controls, quotas, duties. But then a lot of the CEOs thought that this can't be a solution forever, because, okay, if we protect the US market, what about the rest of the world? Japan will just take over the global markets, or other companies from other countries will. And so we can't just stay being behind the cutting edge in manufacturing and just protect the US market. We want to also go and sell on the global stage. And so we have to be efficient and be able to compete with other companies globally. And so they started taking quality seriously, looking at the advice of the quality management experts, and establishing quality management systems. So the TQM approach, total quality management, became very popular in the 1980s. ISO 9000 standard, which kind of stamps that a company has a quality management system in place. It doesn't stamp the company's level of quality on a product. It doesn't measure the quality of products. Like in consumer reports will sometimes compare products on quality or whatever. That's not what ISO 9000 does. It looks at the process and says, does the company have a process to measure and improve quality or not? And so that started being rolled out, and industry organizations started recommending large companies started recommending suppliers to have that certification done. Then a Baldrige National Quality Program was set up with a national award. that was given to companies, and that became a sort of prestige, and companies wanted that award, and so they competed with each other to improve their quality, and that kind of brought energized the quality movement in the US. These are some names of quality management experts. All of them would have some popular books, some classics written in the 80s, 70s. And you don't have to read the classics, but you can if you want to. It's interesting. I've linked to an article which kind of summarizes, some of their ideas and what are some of their popular books. And then there are later, more recent books which kind of summarize that knowledge as well. So Walter Shewhart, he did a lot of work in World War II with statistical process control, which is a key technique in quality control because, companies are always changing, moving because workers leave, new workers get hired, equipment changes, equipment goes old. There's always some change happening in these complex manufacturing systems. And so even if you set up the whole process and system to produce quality today, unless you're able to control it, it will deviate from where it is today over time. And so the idea of controlling and making sure you stay on the, you do not deviate from producing quality, that idea and tools to accomplish that came from Shewhart. Deming, some very key ideas came from Deming. Process capability, focusing on the system rather than people. We're going to look at some of those ideas. Joseph Juran as well. Then some of the Japanese people who really did innovative contributions as well extended the work of the American experts, Ishikawa, Taguchi, Shigo Shingo, and a lot of their names will show up in Lean Six Sigma as well. If you do a course on quality management and say Lean Six Sigma in detail, you'll get familiar with these names again. And then there were later American experts like Crosby and Peters. Okay, so I would recommend, it's not a very long article. You can read this article and then you can go from there, whatever you want to learn about that. And hopefully, I would also recommend you take a full course on quality management and go into detail, say these ideas in detail. Okay, so one of the ideas of Deming that's really important that I want all of you to keep in your head is having the right perspective. Okay? Quality does not come from just having this idea that you can just push people and then about quality. Hey, make sure you do high quality work, make sure you do high quality work and just get good quality. So you can't, from a top down way, just enforce quality and have a quality organization, a quality process which produces quality products. So this kind of, perspective where you are like a boss and you're kind of like, pushing the people to have higher quality doesn't really work. So Deming used to say this in his trainings. 85% of the reasons of failure in Deming's research are related to deficiencies in the system or the process rather than the employee's fault. Because the traditional perspective was, hey, if we produce something defective, obviously, it's coming from some employee. Some employee put it together or was involved in some step of production. Especially in that time, there was not 100% automated production. Even today, we don't have, most things are not 100% automated. There's human involvement, right? And so the natural instinct was, oh, this thing is faulty. Whose fault is it? Who messed up, right? And so Deming is trying to get that mindset out of the managers and telling the managers, okay, instead of putting blame on people, and just trying to beat people up or criticize them and say, oh, must have higher quality, that's not going to work. 85% of the issues or more are because your process is not correct. Your process needs to be improved for a higher quality output, or your systems are not correct. And so that's the role of management, to improve the process and the system, and it's not really the employee's fault. So don't go around blaming employees. Fix the system or the process. So have this perspective. Whenever something goes wrong, ask the question, okay, what can I improve in the system? What can I improve in the process so it doesn't happen again, rather than find and apportion blame on employees. We already kind of mentioned this a few times in the lecture that quality is multi-dimensional. These are some of the dimensions that are popularly considered. Okay, so there's conformance to specifications, which is meeting advertised or implied standards, which relates to conformance quality, meeting specifications, giving on-time delivery to customers. Value, how well the product service serves the intended purpose at a given price. The higher the value, the higher the price customers are willing to pay. Right? So this is about the function, how the product is used. Does it do what it's intended, what it claims to do? What features does it have for the price it's charging? Things like that. Fitness for use, how well it performs its intended function. And these are all related, right? So if you have conformance quality, you're likely to have fitness for use. If your fitness for use, likely to have high value. So it's not that they are these independent things, they're all related, but a little bit of a different angle on quality. Support is the customer support related to the product or service you're selling. So, nothing is really a pure product. If you sell a car, you also sell a warranty with it. You also have a dealership network where you can go to get the car repaired, get your oil change done, things like that. So there's always service and product are intertwined. And there's also very few things are pure service as well. You go to a restaurant, okay, they give you a service, but they also give you food, which is actually a product. So it's product plus service combined. So the support aspect is the service aspect in the product service bundle. How is the communication, the training, or the instructions, the troubleshooting, customer support, returns. So these sorts of things go into support. And then psychological impressions, aesthetics, image, packaging, atmosphere, the looks of the product, things like that. Some of the common methodologies, and as I mentioned, there are multiple quality management systems out there. They all stem from people doing work in different industries and finding ways to do better in quality and then sharing those ideas with each other. And they all are similar. They just may have a slightly different focus, more on one area than the other, but they're all very similar. And if you kind of do learn one of them very well, or you study multiple of them and then you just implement the main ideas, you'll have like a quality management system. You have total quality management, Six Sigma. These are the popular ones. And these methodologies overlap. Some of the common elements you'll see in all of them would be employee involvement and empowerment. As I mentioned, this idea came from Japan. This is not an idea that was used in the US as much initially, and now it is obviously. To make quality a responsibility of all the employees in the company, empower them, give them encouragement to tackle problems and to find improvements and implement them. This is actually very powerful for management students as well, because too often students have this perspective. I'm going to go work in a company. Company's going to tell me what to do. All this education is useless. Like, I'm just doing college to get a degree, and then when I go work for an employer, I'll get on-the-job training or whatever I have to do, I have to learn on the job. While on-the-job learning is really important, no question about that, but this idea that companies know how to do things perfectly, so companies are perfect, they have a perfect system, they have perfectly well-defined roles for each person, and each person will get a set of instructions when they join a company, and that's what they have to do, is completely unrealistic and completely false. That's not how reality works. Companies are, a lot of things are nebulous, not well defined. A company started off, they had a certain process. Now they're growing. The process needs to be changed. The CEO or the president is doing 20 different things. Right? Top management can't come and look at everything and change everything as time goes on. And so if all of the employees have this perspective that we're just going to do what the company told us, ABC, like just follow those instructions and that's all our role is, that company is not going to improve. We know from the many stories and many experiments and seeing many companies, this is true not just for quality but overall, that companies, first of all, are not being run optimally. Every company has room for improvement. The CEO can't go and find all the improvements and then just tell you what to do and institutionalize all those improvements. The CEO doesn't know all the places where there are gaps, where you're not the most efficient, where you're not the most productive. Even top management doesn't know all of them because they have a high level view. They don't know the nitty-gritties of how everything is being handled. And so employees at all levels need to not just do what they have been given, but also study how things are happening, also also experiment with things, also come up with ideas, also implement changes, also improve the company. So and you can't do all of that. You can, but you can't do it as well without any education. What we are teaching you here will help you do that, help you evaluate the company's current performance, help you find where the gaps are, help you think in a systematic way to address those gaps, help you find and evaluate improvement ideas, help you test them, help you implement them. And so this role, often when you sign a job contract, your job contract or job description might not explicitly say that, but unless employees in a company are doing all this, that company is not going to become a great company usually. And so this idea that students have that companies are this perfect, everything has been perfected, all processes have been perfected, and I'm just going to go fit in like a cog and the boss is going to tell me what to do, I'm just going to do that, is a very flawed idea, and it leads to poor companies. And unfortunately, we're seeing that where a lot of people don't really take learning seriously, whether they're in class learning or outside class learning, and they just the status quo just goes on. And companies stay mediocre for years and decades, whereas the problems they have, they could have been fixed in 2 years or 3 years or 6 months. But nothing is changing because the vast majority of employees don't see that as their role. And so this is a very, very important point to keep in mind as an employee, as a manager, that your job is not just to do the current tasks you've been assigned. At least the management, if they're smart, should be telling you that and encouraging you that. In quality circles in Japan, what they found was that they didn't even have to pay people. People would stay back after work because they enjoyed it so much to collect data, to map processes, to improve it. They took ownership of that and they wanted to do it without any extra compensation. So employees would even stay back an hour after work to discuss these ideas, evaluate their processes, find improvements, test the improvement on one assembly line or on one area of the company, then roll it out. And then they would get to present in front of other employees to teach them how to implement this improvement. And they would get this sense of accomplishment. Right? So if you think of psychology, our needs are not just basic needs of humans, having just food and shelter. We also have higher level needs. And so these employees felt like they were contributing, that they were being researchers, they were contributing to knowledge, they were contributing to the company, they were contributing to building a better product for their customers. And a lot of these quality circles, a lot of great ideas came out of them in companies like Honda, Toyota, other Japanese companies. And so it can be very powerful. It can be motivating for the employees. And it's not that you always have to just pay them or you're staying, I'm going to have to pay you for it. And so all companies, no matter what they're doing, they should ask employees to contribute to improving the company, not just running it in status quo. All of these methodologies will have a systematic way to measure, improve, and sustain quality. This is really important. If you don't have a systematic way, you could find something that doesn't really work and you think it works. And so you want to be able to identify the root cause of problems, solve problems in a structured way so that you don't miss anything. You're not looking at only half of the data, you're gathering all the required data, and so on. And all of these quality management systems, their goal is to produce right the first time. Okay, use inspections if you really have to, but inspections are really like a waste in Lean Six Sigma language, because if you're producing right the first time, why do you need to inspect? If you need to inspect, that means your process is not capable to produce the quality you need. That's why you're inspecting, to catch the bad apples and then fix them. But if your process was capable, you wouldn't have those bad units in the first place. And so make your process capable instead of just spending money on inspection. Right? That's the goal. Okay, so now we're going to talk about So just a process capability, which is a very important idea. Then we're going to talk about statistical process control. But before we can really understand, and actually, unfortunately, many books do not do that. I mean, textbooks, they don't really help you understand the issue with variation and why we are doing all that. And sometimes they don't even teach you process capability, they just get into process control charts, which makes no sense. First, you have to understand the role of variability in the processes, and then you have to understand process capability, and then you can understand process control charts. Then you understand why they work and why we use them. So that's going to be our next part of the lecture. We're going to look at how Deming taught people about understanding variation in processes. And I think Deming had an excellent way to teach this thing. So I'm just going to use what Deming did. So you're going to get from me exactly what Deming would teach you on how to understand variation. Then we'll use that understanding to understand what is process capability and where do statistical process control charts fit in.